Okay, so here we are alongside one of the prime movers at the CHP plant, the steam turbine, 25 megawatt steam turbine. To my right, we have a 45 megawatt gas turbine. Both turbines have online vibration protection, which are monitoring the shaft movement of a shaft and a journal within a white metal lining. So we're dealing here with a white metal bearing, hydrodynamic bearing configuration, or a sleeve bearing, some people call them. We have X and Y probes looking at the gap of between the probe tip and the actual shaft within the bearing itself. So it's measuring the movement of the shaft in free space. This shaft is running at 9,000 RPM. Now, we have machine protection and we have machine prediction. We're going to just talk about the machine prediction side of things, where initially we're going to take some measurements on the casing of the bearing, but it's very important to appreciate that we also need to measure dynamically the probes themselves. We'll look at that a little bit later on. So initially I'm just going to show you taking my measurements in 3 axes on the sleeve bearing at the non-drive end of the high pressure end of the turbine. So just like before, we're going to take our casing sensor and place that in the shaft center line horizontally to take our horizontal casing measurements. So here I am just about to acquire an FFT. I'm going to record the megawatts at this particular point. So I'm just going to key in the megawatts today. So I'm recording the load and I'm capturing an FFT. So I'm measuring the dynamic signal by the casing of the steam turbine here on the bearing pedestal. I'm going to move my sensor to the vertical direction. It's important we consider more than just one direction. We need to understand how the machine's moving in 3 axes. Okay, so I'm done there. And then finally, to finish off, I'm going to measure actually at the non-drive end of the pedestal on the casing to measure the actual vibration here. Okay, I would then move on to measure the low pressure end of the turbine in the same way, the gearbox and indeed the generator. But we said before, it's very important we also measure the dynamics of the shaft itself. So we now need to measure the dynamic movement of the shaft with our signal data acquisition device in the control room, where we can plug into remote probes that reflect the X and Y probes of this bearing pedestal. Okay, so here we are alongside the 45 megawatt gas turbine referred to earlier. The power turbine end does about 10,200 RPM. The compressor end does about 3,500 RPM. And via a gearbox that reduces down to 1,500 RPM. And the gearbox obviously drives out to the generator at 1,500 RPM. Access here somewhat more difficult than the steam turbine that we saw before. However, we're going to go now into the control room and plug into the XY probes and the casing measurements that are actually accessible at a panel in the control room to look at our dynamic data for more predictive diagnostic purposes. So let's go and take a look in the control room. Okay, so here we are at the gas turbine protection system. It's important to understand that a protection system is there in the event of a catastrophic situation happening, some sudden change in machine dynamics that is going to cause damage to the machine, that would shut the machine down. The purpose of what we're going to do now is actually more focused on prediction. So we're going to plug into the XY probes and any casing measurements that may be applicable as well, and look at the dynamic movement of the shaft in free space and predictively trend the heartbeat of the gas turbine that we spoke about a few seconds ago outside. So first off, I've got a speed reference signal. So I've got a key phaser channel. That's where my speed signal comes from, and that's a reference. It's a good datum point that I can use as a trigger and understand point by point by point how the motion of the system might be but maybe that's something for another time. I've got 2 channels. I have 4 channels of capability, but I'm going to plug 2 dynamic channels in. The first being the X channel, channel A. So I'm just looking on my data collector here to get the right position. 16X, that's channel A. That's good to go. And then my Y probe, proximity probe again, is on channel B. So just plug those in. A key point here is we're going to collect the data simultaneously. We've got a reference, a trigger to trigger our collection from, and indeed the timing of that collection as well. The speed is currently read out on the screen. I can clearly see the speed updating. And most importantly as well, we've got to think about process parameters. I would enter in flow rates, I would enter in temperatures and so forth, but equally before I start my vibration readings, I would record the load. So I'm just going to type in the load here, and then I'm going to collect the actual FFTs. I'm measuring the FFT raw dynamic signal coming out of those X and Y probes to look at the motion, to look at the heartbeat of the machine, providing more predictive information, more detailed, more finite changes that may be occurring. That's an important building block to add on to the protection that exists in the first place. I'm then going to move my X and Y probes to the other bearing journal on the gas turbine. So I'm now plugging into the other bearing, the X and the Y, giving it a few seconds to stabilize, because equally whenever we plug into a channel, it's important we allow the signal to stabilize again. So that's after a few seconds now stable. I can validate the data again by watching what I'm measuring. I've got nice clear FFTs on the screen, my time waveform. I'm measuring the DC gap voltage at the same time, an important measurement to understand where the shaft center sits in free space within that bearing journal. Because don't forget, we're measuring the dynamic movement of a shaft in free space separated by a film of oil and a white metal lining in the bearing. And I will continue my measurements through and take a full sweep in a predictive context from each X and Y probe. And on the gearbox there may be a casing sensor that's fitted permanently, and I take it from there as well. And then go on to record the process parameters, the flows, the temperatures and so forth, in addition to the vibration readings I've measured.